Concepts of chemistry. We will start with an atom. So, what is the definition of an atom? Atom. Simply, I can define atom is an indivisible particle. Simply, an atom is indivisible particle. Indivisible. So, atom can be studied under two headings. One is nuclear part. One is nuclear part. Another one is extranuclear part. One is nuclear part. Another one is extranuclear part. What is a nuclear part? Atom has two parts. One is nuclear. Another one is extranuclear. In the nuclear part, we have neutrons and protons. Extranuclear part, we have electrons. So neutrons, as we know, neutrons are chargeless particles. Neutrons are chargeless, means zero charge. Protons are positive charge. Protons are positive charge. So what is the overall charge on the nuclear part? Overall charge on the nuclear part is positive. So overall charge positive charge. Here we have only negative particles, electrons. So what is the overall charge on the extranuclear part? Overall charge is negative charge. We'll see now the terms related to the neutrons, protons and electrons. Very important in your basics of chemistry. Important in your basics of chemistry, and some questions are asked in JEE, NEET and mains from basics concepts of chemistry also. Terms related to neutrons, protons and electrons. What are the terms we have in atomic structure which are related to the neutrons, protons and electrons? First one is isotope. Isotope. How can we define an isotope? Isotopes are same atomic number and different mass numbers. Same atomic number means nucleides are the same. So we can define isotope is two nucleides of same element have different mass numbers. Are different mass. If you write examples, C14 and N14 are isobars to each other. We have argon 40 and calcium 40. These are also isobars to each other. The next term, isotones. Isotones are the nucleides of two different elements. Which are having same number of neutrons. Examples: C14, C614 and 16, 8. How can we calculate number of neutrons? Number of neutrons is equal to mass number minus atomic number. Mass number minus atomic number. So here in this case is 614. 14 minus 6 is 8. 8 was 16. 16 minus 8 is 8. So same number of neutrons. So these two are act as isotones to each other. The next important one is isodiaphers. Creates having same isotopic number. Isotopic number are called isodiaphers. Isotopic number means indirectly A minus 2Z. Or we can write the two nucleides with same n minus p value. Same n minus p value. Example. Fluorine 9F19, sodium 23 and 11. So what is the n value in 9F19? 19 minus 9, so it is 10. Here 23 minus 11 is equal to 12. N minus p value. What is the n value here? 10 minus 9 is equal to 1. Here n value is 12. 12 minus 11 is equal to 1. So 1 is 1 n minus p value in the both cases. So these two are act as isodiaphers. Important. Next term is isosters. Isosters. The molecules. Next term is isosters. The molecules with same number of atoms with same number of electrons same number of electrons. Here you should notice one point. Same number of atoms is nothing but atomicity. Atomicity is nothing but number of atoms in one molecule. Isosters. Examples: N2O, CO2. First of all, we'll check the first condition, same number of atoms. So what is the atomicity? 2 nitrogens and 1 oxygen is there. So atomicity is 3. Here one carbon, two oxygens are there. Atomicity is 3. So first condition is valid. Second condition, number of electrons. Here, how do we calculate number of electrons for a molecule? Is just we need to add number of electrons in each atom. Number of electrons in each atom. For example, N2O. N as atomic number 7, like that 2 are there. So 7 into 2 plus oxygen is 8. So 14 plus 8, 22 electrons. 14 plus 8, 22. Coming to the CO2, C has atomic number 6, oxygen has atomic number 8, 8 into 2, 4, 16, 16 plus 6, 22. So same number of electrons and same number of atoms. So these two are act as isosters to each other. Previous year MSET question. Which of the following phase are isodiaphers to each other? Option A. CONO. Option B. CO2 NO2. Option C. C6H6. B3N3H6. Option D. NO2 SO. So here the answer is CO and NO. Same number of atoms but same number of electrons are not satisfied. Same number of atoms, no electrons are satisfied. Same number of atoms are there but electrons category are not satisfied. Coming to the option C is correct answer. I will explain you why option C is correct answer. Take C6H6. How many atoms are there? 12. How many electrons? Carbon has 6 electrons into 6 plus hydrogen is 1 electron into 6. So 36 plus 6, 42. Coming to the B3N3H6. B3N3H6. So boron atomic number is 5. So 3 into 5 plus nitrogen atomic number is 7. 7 into 3 plus 1 into 6. 15 plus 21 plus 6. Again it is 42. So answer is C. Next important term is isoelectronic species. Very, very important. Isoelectronic species. Here, the molecules are ions which are having same number of electrons are isotonic to each other. Isoelectronic species, it could be species, molecules or atoms, simply ions also. But they should have same number of electrons. No other category is required. Just if it is having same number of electrons, then those are called as isoelectronic species. For example, Na plus Mg plus 2. Na plus means how many electrons are there? 11 minus 1 is 10. How I written 11 minus 1 atomic number is 11 plus means we need to remove 1 electron, so 10 electrons. Coming to Mg plus 2, 12 minus 2 is 10 again. So like that molecules or either atoms are receiving ions which are having same number of electrons, those are called as isoelectronic to each other. So some questions have asked in exams from isoelectronic species. Na plus and Mg plus 2. These two are isoelectronic to each other, as you know. So here size means if you take Na plus, so 2 comma 8 comma 1, here 2 comma 8 comma 2. If you remove 2 electrons in Mg, 1 electron in Na, so the third cell disappears, the second cell becomes the third cell. So now what happens, the distance between center to the last cell is decreases. So more attractions on the last cell when compared to the sodium atom in sodium plus ion. So when more attractions are there, the cell sinks towards the nucleus. So size decreases. Size decreases. So every time it is not possible to imagine like that. So simply we can calculate P by E ratio. Here P means protons, E means electrons. If P by E ratio increases, size decreases. So remember this relation. Remember this relation that will help you in so many cases. So first of all, Na plus. What is the P value? P is nothing but protons. Protons is nothing but atomic number. Atomic number does not change even an atom converted into ions. So number of protons are 11. Number of electrons are 10. So P by E ratio is 1.1. Mc plus 2. Proton P by E ratio. Protons are 12, electrons are 10 only because those are isoelectronic. So 1.2. P by E ratio increases, size decreases. Now, so P by E ratio is less for Na plus. So size is Na plus is more than Mg plus 2. Mg plus 2. One more question. Question in the previous exam. Arrange the following in increasing order of their size. The species given as C minus 4, silicon plus 4, N minus 3, Al plus 3, O minus 2, neon, sodium plus Mg plus 2, O minus 2, F minus 1. F minus 1. These are the ions they are given. So what should we do? We need to arrange the given ions in increasing order of their size. So for these type of questions we have one shortcut. If positive charge increases, size decreases. If negative charge increases, size increases. Just remember the shortcut. This is applicable for only for isoelectronic species. Isoelectronic species. We'll see. Coming to the C4 Si plus N3 plus Al plus 3 O2 minus Al plus 3 Na plus 1 Mg plus 2 O2 minus, it is repeated, sorry, NF minus. So if you are not able to compare the sizes at the time, so better calculate P by E ratio. As we know already, P by E ratio increases, size decreases. So P by E ratio is highest for C minus 4. Shortcut method, plus V means positive charges increases, size decreases, negative charge increases, size increases. So P by E ratio increases, size decreases. If you take the ions P by E ratio, C minus 4, protons are 6, electrons are 10, 0.6. Si plus 4, protons are 14 and 10 electrons 1.4. Next one, N3 minus, protons are 10, protons are 7, electrons are 10, 0.7. Al plus 3, protons are 13 and electrons are 10, 1.3. O minus 2, protons are 8, electrons are 10, 0.8. Neon, protons are 10, electrons are 10, so 1. Next one, Na plus 11 by 10, 1.1. Mg plus 2, 12 by 10, 1.2. F minus 9 by 10, 0.9. If you increase in an if you wanted to increasing order of size, means we need to start from least size to highest size. Least size is always from highest P by E ratio. So silicon plus 4 is least one. Then Al plus 3. Then Mg plus 2. Then Na plus neon F minus O minus 2. N minus 3. C minus 4. That is your answer. Increasing order of size. So many questions are asked regarding isoelectronic species. Size order is important. Thank you for watching. Please subscribe.